Good morning, good evening, good afternoon, good whatever time of day it is and whatever part of the world you're at right now. Welcome back. And today we're going to go ahead and continue with part 2 of our video, of our lesson about proving triangles and their congruency. Okay, so these next couple of examples are basically proofs here. Okay, so we always want to start with the given information. Says segment QS bisects angle PSR and angle QPS is congruent to angle QRS. All right, so when we're filling in we have our diagram here. We're going to need to label our diagram properly based on the given information. So first thing, it says that segment QS bisects angle PSR. Okay, so if it does that, and they tell us that angle QPS is congruent to angle QRS. Now, so the first thing we need to do is start with the bisecting part. With the angle bisector, QS is going to make angle PSR is going to cut it in half. So PSR is this angle. These the two smaller angles are now congruent. So angle QSP going this way, QSP, and QSR, both of those angles are now congruent. Okay, as a result of that bisector. They also tell us that angles QPS and angle QRS are also congruent. So we have to do those markings as well. Okay. And as a matter of fact, I'm going to color code these markings. So the first ones I'll do in blue. The next ones I'll do with the orange. Okay. Which are right here. Now, the last thing we need to do that they didn't tell us, but it's indirect, is that QS this is also an example of a shared side. Okay, QS is what we have our reflexive property. Okay, now, so in this diagram over here, I'm gonna just put shared side. All right, now we need to just go ahead and put our reasons. So for number one, anytime you do proofs is going to always result in given. Okay, that's given information. That's what they gave us. Number two, angle QSP is congruent to QSR. QSP is congruent to QSR. So QSP is congruent to QSR. So those two angles are the result of the angle bisector. So that's what we're gonna put is just angle bisector, or definition of angle bisector. I'm just gonna write angle bisector because that's why those two angles are congruent. Angle bisector. Now, it's asking us, the third one says segment QS is congruent to segment QS. That is the reflexive property. So that's all we're going to put here, reflexive property. That's the shared side. Okay. And actually, we can also write shared side right here. Another way to really hit that home. And the last one, triangle QPS is congruent to triangle QRS. Why is that? Well, let's see. We have a angle here, and we have a side. So angle, side, or angle, side. Now, with that being said, that's the reason why, excuse me, these two triangles are congruent, angle, side. All right, number 19. The given information says E is the midpoint of CG of segment CG and segment DF. So, if that's the case, first, let's identify E. E is right here. Now let's use the black. Here's E, and it's the midpoint. So if it's the midpoint of CG, then CE is congruent to GE. And if it's the midpoint of DF, then that means that DE is congruent to FE. Okay? Now, what we also have here as a result are what we call our vertical angles. Okay? And our vertical angles are congruent right here around the midpoint where they intersect. Oops. Now that we have that, we can go ahead and pretty much label this. This is going to be side, angle, side, and side, angle, side. So number 4, if you want, you can just fill that part in, side, angle, side. Number 1 is going to be given. Again, that information was given to us. All right, given info. Segment DE is congruent to segment EF, and segment CE is congruent to segment EG. That is our definition of midpoint, right? So we can just say midpoint for short. And angle DEC is congruent to angle EFG. That is from our vertical angles. Okay. All right. Let's take a look at number 20. Number 20, given information tells us segment AB is parallel to segment CD, and segment AD is parallel to segment BC. All right, so we have to put our markings up here. AB is parallel to CD. So if they're parallel, there we go. Now, the other two segments that are parallel are AD and BC. Now that we've put our markings up there, we need to go ahead and fill out our diagram. Now, as a result of this as well, we have here our reflexive angle, our reflexive property, which gives us our shared side. Okay, right here in the middle is our shared side, and we have some congruent angles, alternate interior angles, right here. And I'm going to use another color. We have another 2 right here. Okay, with the purple. So, and just in case you don't understand where those come from, I'm going to imagine if these were 2 parallel lines. Okay, and here is a transversal that cuts those 2 parallel lines. All right, that's where the angles come from. And also, if you looked at it like this as well, because these would also be parallel, and then you would also have a transversal right here. And our alternate interior angles would be right here and right there. And the same for the orange as well. Okay, so that's where those exaggerations come from. There we go. Let's see. Put our marking back here. All right, so now that we have that cleared up, we can go ahead and go through our diagram. Okay, the number 1 once again is given. Okay, number 1 is given. Now, one thing we did forget to do was label our sides and angles. So we have a angle, we have a side, and we have an angle again. And the same thing, angle, side, angle. Okay. And let me just emphasize that the given information helps you to determine whether angles are going to be congruent or sides are going to be congruent. In this example, it helped us determine that the angles were congruent. The other thing that helped us determine if a side was congruent was the reflexive property. Okay, but the given information, you always have to use the given information to help you add markings to your diagram, so that way you can identify what the congruent angles are and what the congruent sides are. Okay, so getting back to our proof, number 2 says angle BAC is congruent to angle DCA and angle DAC is congruent to angle BCA. Those are the markings that we labeled in the diagram, and all of those were due to alternate interior angles. They are all congruent because those are all sets of alternate interior angles. Okay. Now, segment AC is congruent to segment AC. That is basically the reflexive property. And number 4, the last one is we're gonna call that angle side angle. Okay. Number 21. Number 21 says segment KL is congruent to segment MN, and segment KM is congruent to segment NL. Okay, so let's see here. KL is congruent to MN, and KM, which is basically this entire line, is congruent to this entire line. Okay, so with that being said, I'm gonna put these markings here. Oops. And for this one, I'm putting the markings near the intersection. Okay. Now, also, as a result of that intersection, we have what we call our vertical angles, right? So we have vertical angles right here as a result of that intersection. What else? They also have a shared side. Here is a shared side, 1, 2, 3. And really, to get rid of these vertical angles, let's see here, because we're not gonna need them for this diagram. Okay. We don't know if we can't prove that LP is the same as MP. We can't assume that they're congruent. Okay, so because of that, this is all the information that we can derive from our diagram, so we can go ahead and fill in everything. The first piece was the given information. Okay. Then number 2 is basically our reflexive property, because it's a shared side. And the last one is which we didn't label. I forgot to label here, but it's side, 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 and side, side, again, side. So side, side, side. And also for number 2, that part, remember we can also put that these are a shared side. And even back for number 20, once again, this was a shared side. Okay, I don't know if we had that anywhere else. No. All right. Now the last one, number 22, and that'll conclude part 2 of our lesson. Okay. So for number 22, it says triangle ABC has the coordinates A, -8, 5, B, -4, 8, and C, -7, +2. If triangle DEF has coordinates D, -2, -1. E, +2, +2. What must the third coordinate of F? What must the coordinates? What must be the coordinates of F in order for triangle ABC to be congruent to triangle DEF? Explain why the triangles are congruent and prove your answer using coordinate methods. Now, the first thing we're going to need to do for number 22 is plot triangle ABC. Okay, they gave us all the coordinates, so let's go ahead and plot it. And for triangle ABC, I'll use purple. Okay. And for triangle DEF, I'll use red. So for triangle ABC, let's label our X and Y axis first of all. Here's our X axis, all right? Here's our Y axis, okay? And as a matter of fact, I'm gonna write X axis on the other side over here, X axis. Now I'm gonna go ahead and plot those points. A is at -8, +5. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Let me count that. 1, 2, 3, 4, 5. So there's A. Then B is at -4, +8. 1, 2, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, which is about right there. So that's B. And then C is at -7, +2. 1, 2, 3, 4, 5, 6, 7, and then 1, 2, which is right there. So that's C. And now I'm just gonna connect them. All right, now we want to go ahead. We can plot the points for D, which we only have 2. We don't have the whole triangle. So -2, -1, -2, -1. That's D. And then we have E, which is +2, +2, which is right here. And I put D in the wrong spot. I apologize about that. D really should be -2, -1 is right here. That's D. And then E is right where I left it. Now we need to figure out where F goes, okay? So one thing that we need to do is figure out the distance between all 3 of the points in the first triangle, ABC, okay? So what I'm gonna need to do right now is say this is gonna be triangle ABC over here. And I'm gonna do all the distances. So from A to B, square root, all right? Distance formula. So we're gonna do, and just in case, let's go ahead and write out the distance formula before we start anything. So D is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Now we'll go ahead and do the work for triangle ABC. And finding the distances. So from A to B is the square root of -8 minus 4. Oh, excuse me, minus -4 squared plus 5 minus 8 squared. When you work that out, that's going to become the square root of, it's going to be -8 plus 4, right? Because right here, excuse me, these subtractions, this becomes a plus. So -8 plus 4, That's going to become negative 4 squared plus negative 3 squared. If you keep working that out, that's going to give you 16 plus 9, which is equal to the square root of 25, which is equal to 5. Okay. Now we have to do the measurement of B to C. So B to C. Now the reason we're doing this because we need to figure out which distances are the same, and then we'll be able to come up with our point. Okay. So let's see here. BC, distance from B to C, that's gonna give us our square root of negative 4 minus negative 7 squared plus 8 minus 2. Okay. Working this out, we're going to have to circle right here. We have a double negative, so that's going to become a plus. Now that's going to become 3 squared plus 6 squared. Okay, that's gonna equal the square root. That's gonna equal the square root of 9 plus 36. Oh, excuse, yeah, 9 plus 36. And that's gonna equal the square root of 45. And we'll leave it like that. We can simplify it, but we'll leave it like that for right now because we don't need it. We don't need to be that specific with the square roots. Now, the last one we need to do is A to C. So A to C, that work there is going to give us the square root of negative 8 minus 7 squared. Excuse me, minus negative 7. Keep making that mistake. Erase. Put the negative 7, square it, plus, then we're going to have 5 minus 2 squared. We continue working that out, right? We're going to have a situation with the double negatives again, where we have to add, okay? So that's going to become negative 1 squared plus 3 squared. Negative 1 squared is just 1. 3 squared is 9. That's going to give us the square root of 10. Okay. So, oops. Let me do that. There we go. So we have 5, the square root of 45, and the square root of 10. Those were the measurements for triangle ABC. Now for triangle DEF. Triangle DEF, we only can do the distance between D and E. Okay, so let's figure out the D and E first. And the distance between D and E. So we have to do the square root of, that's going to be negative 2 minus 2 squared plus negative 1 minus 2 squared. That's going to give us negative 4 squared plus negative 3 squared. And of course, that's going to give us 16 plus 9, which equals 25, and the square root of 25 is 5. So we actually know that D to E is the same distance as A to B. So now what we need to do, what we could easily do here to figure out F, is look at the distance between A and C. Okay, so real quick, if we take a look at the distance between A and C, distance between A and C is basically 3 cubes stacked vertically. So if I start at D, is the same as A in DEF. So if I start at D and I go down 3 units vertically, okay? And I stack them, cubes. The bottom right-hand corner has to be the point F. So now from there, we can go ahead and connect the rest of those dots. And we've drawn our triangle, okay? Most important thing is, what are the coordinates of F? The coordinates of F, right? Coordinates of F are -1, comma, -4. Okay. And that'll be our final answer there for number 22. F is -1, comma, -4. Have a great day, and I'll see you all back for another video lesson. Deuces.